Okay, for example 2, another very, very similar problem. You've got example 2, the series n all over 2 to the n times n plus 1. In other words, a sub n is this form right here. Now, of course, to really investigate what's happening, we're going to have to keep going. The b sub n, what you want to do here is try to omit one term so that some good canceling will occur. And even more importantly, you're going to arrive at a geometric series or a piece series. What do you think we might lose here? What might we omit? What do you think? The plus 1, I heard someone whisper. You're right. Sometimes kids will say it's kind of like end behavior. Yeah, kind of. I mean, it's really end behavior is better seen in our last part of the lesson. What you're trying to do is just lose one term so that some nice canceling will take place. You can see right here the n's are going to go away, and you're left with 1 over 2 to the n. From the very beginning, here's the way some kids begin to look at it. Ooh, there's something geometric, and very likely we might be able to get some canceling to occur. So you begin to preview the problem, so to speak, and you begin to try to see a p-series or a geometric series that you're moving towards. Now, by the way, we'll talk about b sub n in just a moment. If I lost an addition of 1, if that's what's been omitted, what happened to my denominator is I lost that addition of 1. It got smaller. And when your denominator gets smaller, what's happening to your fraction? It gets bigger. So what's happening? You could say that this fraction is actually bigger than a sub n. Well, that's necessary. To do the basic comparison test, that's bare minimal. You have to have that. But then you also have to name this b sub n right here. You got to say, wow, what exactly is happening right here? You can say, what type of series is this? Heard somebody say it. Geometric. It's a geometric series. Look, if you were working this out, I'll even jot it off to the side. You get 1/2 plus 1 over 2 to the second plus 1 over 2 to the third. Your r very clearly is 1/2. And you could say r is equal to 1/2. You could say the absolute value of r is less than 1. You could say this is a convergent geometric series. Right? So we're looking at our newly created series. We know that it is a convergent geometric series. We also know that b sub n is larger than a sub n. Let me draw your attention back to the first picture. This is honestly what we're seeing right here. B sub n, which is our geometric series, converges. It's going to level out. It's going to flatten out with its partial sums. A sub n is always smaller. So it's really bound to stay below those blue dots. So we're guaranteed to get convergence for our original series as well. So how do we write this? We can say by the basic comparison test, the original series converges also. And you can just say converges. But again, notice the work that is really required. Again, you're showing your choice of a b sub n. You're talking about relative size between the original series and your series. You're making a statement that b sub n either would converge or diverge. And finally, you make use of that situation, of those two pictures. So look, before we go to the back page, I do want to state one further thing and this is so important, guys, please understand that the basic comparison test can have limitations as well. What if, instead of being told that A sub n was always less than B sub n, what if we were told that B sub n converged, but A sub n was always bigger? So now I'll go to black stars. Are we guaranteed that black stars have to level off if I just know that A sub n is bigger? No, it's in the realm of possibility that those black stars could just all of a sudden launch off and start going higher and higher and higher. So if you know that B sub n converges, but A sub n is actually larger, we just don't know. Likewise over here for number 2, you could say, what if B sub n, it's diverging, but what if instead A sub n was less than B sub n? All of a sudden I've got black stars. Are we guaranteed that the black stars have to launch off towards infinity? Well, no, we might all of a sudden get a surprise and say, hey, guess what? Yeah, A sub n is smaller, but maybe it curves off and begins to level off. So there are limitations to the basic comparison test. You have to have one of those two pictures that you're seeing with the relative size relationship as well. Tell you what, we're going to end this video